Let's start with a straightforward engineering fact. Any medium with stiffness, joules per meter cubed, and distributed inertia, kilograms per meter cubed, supports waves at a finite speed. For the vacuum, we'll call the stiffness 1 over epsilon, the distributed inertia, mu, and the resulting wave speed is c, given by the propagation equation. Now imagine that everything we call matter is actually a stable defect, a persistent void, a stable topological defect in the substrate. The medium has to distort around that void, and that distortion is the equilibrium field, phi. In a linear medium, the equilibrium field is this, where ρ void is the displaced substrate energy, and K is the coupling proportionality constant between the amount of displaced substrate energy and the curvature of the equilibrium field. This is the mechanical origin of Newtonian gravity. The medium wants to relax, and two voids lower the total distortion energy by moving closer. Attraction is just relaxation, but the medium is dynamic, not static. Disturbances propagate at speed c, so the full equation is the relativistic propagation equation, where the box symbol is the 4D wave operator. This is the substrate's version of a gravitational field equation. Now here's where relativity enters. Clocks and rulers are made of waves in the medium. A simple light clock shows that if the clock moves sideways with velocity v, the wave must take a diagonal path. The tick time becomes the time dilation relation with the Lorentz factor. Time dilation isn't a postulate. It's the geometry of wave paths in a moving pattern. And the same logic gives length contraction and the invariance of the interval in the Minkowski metric. This is the natural bookkeeping system for a medium with finite signal speed. Now combine relativity with the relaxation field, phi. Clocks slow down in regions where the medium is more distorted and rulers shrink. To first order, the effective metric becomes the curved space metric. This is exactly the weak field limit of general relativity. When the substrate is distorted, the local wave speed changes, and that variation is what we mathematically encode as curvature in the metric. But in this picture, geometry isn't fundamental, it's emergent. The compressed description of how the substrate's equilibrium field alters clocks, rulers, and wave propagation. Freefall becomes motion along paths that minimize the substrate's reconfiguration cost. Those paths are geodesics in the effective metric. General relativity describes the shape of the equilibrium field. The substrate model explains why that shape exists. So the full picture is this. Matter is a void. Gravity is the medium relaxing around voids. Inertia is the medium resisting rapid reconfiguration. Relativity is the medium enforcing its finite wave speed. And spacetime geometry is the language we use to describe the medium's behavior. This is a mechanical, substrate-based origin for both relativity and gravity, one that makes the whole structure feel inevitable rather than mysterious.